Now that you know how to find the gradient at any point on a curve, you can find a point that has a certain gradient. So how do we do that? Well, first step, you need to differentiate whatever function you're given. Second step, let your derivative equal whatever gradient it is that you're trying to solve for, whatever gradient you want. Solve it for x. Then sub x back into the original function, that's the function that describes the actual curve, to find the y value that corresponds. And then write your coordinate point clearly. So that means with brackets and two numbers with a comma in between them. So let's have a look at this example. We want to find where the gradient is horizontal. Now think, a gradient that's horizontal, that means we want a gradient that's equal to 0. So if we want the gradient equal to 0, we want f dash x equal to 0, don't we? Now here's our function, f of x equals 4x minus x squared, and it's asked us also to sketch the curve. Alright, so first thing I need to do is I need to find f dash x. So I differentiate this. 4x differentiates to 4. Minus x squared, I bring the 2 down the front, multiply it by minus 1, and I have minus 2x. So this is my gradient function. It will tell me what the gradient is at any point that I want to investigate, or I can find where the gradient is a certain thing. So if I want to let f dash x equal 0, because I want to find where the gradient is 0, then if f dash has to equal 0, then 4 minus 2x also has to equal 0. So I write, therefore, 4 minus 2x equals 0. Now we just need to solve this little equation. So we have 4 is equal to 2x, so x is equal to 2. So that tells me that the gradient is flat or horizontal when x equals 2. Now, x being 2 doesn't give me an actual point in space. I need a coordinate point. So I write, when x equals 2, y equals what? Now, the easiest way to write what I'm doing is to say, let's find the function of 2. In other words, let's sub 2 back into our original curve function. Well, 4 2's are 8, minus 2 squared of 4. 8 minus 4 gives me 4. So that tells me, therefore, at 2, 4, I have, oh, I can't quite see that. At 2, 4, the gradient is 0. Now, how do we go about sketching this thing? Well, I know that it's a parabola because it's got x squared. I know that this negative x squared tells me that it's upside down, so it's shaped like this. Now, if I want to find the x-intercepts, I need to just let y equal 0. So if I let y equal 0, it's the same as letting f of x equal 0. I've got 4x minus x squared equals 0. If I factorise that, I get this. Now, what this means is that either x is 0 or 4 minus x is 0, in which case x would have to be 4. So I can tell here that x has to be 0 or 4. So those are my x-intercepts, 0 and 4. And I know that when I'm at the point 2, 4, which will be here to, let's say up here, 2, 4, that's my turning point, because that's where the gradient is going to have to be 0. And you can see that a tangent at that point would be flat. You'll also notice that when you're drawing a parabola, that turning point is the x value of it's halfway between the intercepts. So that's just a nice little check that I can do to check that what I've done makes sense. This is going to be 2 and it's halfway in between.